In this video, we are going to discuss how to write and balance formula equations. So I do this as a 3-step process. The first thing I do is I look at the paragraph of information I've been given and I focus on writing the word equation. Once I'm sure that my word equation is correct, I move on to step 2, where I write the formula equation. The easiest way to do this is start with your simplest formula first. So the diatomic elements, then your prefixes, then your valency rules. At this step, I would also put in the state symbols if you're asked for them. And then step 3. This is where you start to balance the formula equation. So you want to make sure that you have the same elements and the same number of atoms on each side of the arrow. And there are a few ways that you can make this easier on yourself. The first is if you have the atoms carbon, hydrogen and oxygen in your formula equation, you go in CHO order when you balance. So you balance carbon first and then you move on to hydrogen, hydrogen first and then you move on to oxygen, and so on and so forth. When it comes to balancing all formula equations, I would advise you remember to do your left to right check. Okay, so after every single change you make, you go right back to the left hand side to the very beginning of the formula equation and you count all your atoms again. And you'll hear me mention this as we move forward. Let's work through some examples together of writing and balancing formula equations. Here we have our first little paragraph. Sulfur burns in air to form sulfur dioxide gas. So the first step is to write your word equation. Sulfur burns in air to form sulfur dioxide gas. So when you see to form, to produce, to create, to yield, you know that anything that comes after that is going to be your product, i.e. the thing that is created, the thing that goes on the right hand side of your arrow. So we can write in sulfur dioxide here. Sulfur burns in air, so our two reactants are sulfur and oxygen, because it's the oxygen part that is going to combine with the sulfur during combustion. So that's step 1 done. That is our correct word equation. Step 2 is to start writing our formula equation. And you start with the easiest formula first. So for me, that's the sulfur. So you can put sulfur in. We're saying sulfur burns in air, so I'm going to say that sulfur is a solid or state symbol. Oxygen is one of our diatomic elements and it is of course a gas. Remember, there are 7 diatomic elements you need to know off by heart. I bring clay for our new house. Iodine, bromine, chlorine, fluorine, oxygen, nitrogen and hydrogen. And here we have sulfur dioxide. We've got our prefix in there. So we know we've got 2. So S1, O2, which we can of course just write as SO2. And now we want to check it and we want to start to balance it. That's step 3. So the first thing that I do when balancing an equation is I just copy down exactly what I had in step 2. Should have put that in there. It's easiest. And then we start with our left to right count. So sulfur, we have 1 over here. If there's no little number after or big number at the front, it means we only have 1. So 1 sulfur, and we have 1 sulfur here. Remember, this 2 relates to the element directly before it, not all of them unless it's in a bracket. So 1 sulfur, tick, correct. Now we have 2 oxygens and 2 oxygens. So this is finished. This is a balanced equation. Let's move on to a far more complicated example. Hydrochloric acid and calcium hydroxide react together to form calcium chloride and water. So again, the first thing that I would do is write your steps down at the side. Step 1, you know, it's going to be your word equation. Step 2 is going to be your formula. And step 3, our focus is on balancing. So let's write this word equation together. Hydrochloric acid and calcium hydroxide react, so they must be our reactants. So we can start writing that in. React together to form calcium chloride and water. So here we have our two products, calcium chloride and water. Step 2, write your formula, starting with the simplest. So for this equation here, the easiest formula by far is the water. We know the formula for water is H2O, and we know the formula for hydrochloric acid is HCl. However, from these words we can't actually work out the formula off the top of our heads. There's no prefixes, so what we must do is use our valency rules. So on a spare bit of paper, what I would do is I would be writing out the name of my compound, calcium hydroxide, and symbol valency swap divide formula, and then I would be working through my valency rules. So calcium Ca, hydroxide is a group ion, you find it on page 8 of your data booklet. Calcium's in group 2, has a valency of 2. Hydroxide has a 1 negative ion, so its valency is 1. Swap them, cannot divide them, so our formula is CaOH minus and 2. And then we can substitute this back into our formula equation. And we would need to do the exact same for calcium chloride. So here we have our correct formula equation, and now what we have to do is balance it. So again, the first thing I would do is just copy it down directly underneath. Now the reason that I say to copy it down directly underneath and not just complete step 3 on top of step 2 is that if you make a mistake in step 3, it can be sometimes difficult to look back and see your correct formula, so you can kind of get caught up in a loop. So here we go. And now it's not CHO elements, it's not carbon, hydrogen, oxygen. Okay, so we can ignore that. We can start in any order you want, and you do your left to right check. So the thing that I would start with would be my chlorines. So here I have 1 chlorine, here I have 2. I need to make sure that there's 2 chlorines on this side. Now you cannot break into your formula. These are in little boxes. If you imagine, all you can do is add multiples of these. So what I would do is I'm going to put a big 2 at the front here. Now this now means that everything after that 2 is multiplied by it. So I have 2 hydrogens and 2 chlorines here. And this is our left to right check. So I've now got 2 chlorines and 2 chlorines. Hydrogens, I have 2 hydrogens here and 2 hydrogens there, but I only have 2 hydrogens over here. So what can I do? got 4 on this side, 2 here, so I'm going to put a big 2 at the front. Now I have 2 hydrogens plus 2 hydrogens, 4. 2 times 2, 4, excellent. And let's finish the check. I've got 1 calcium and 1 calcium, that's balanced, good. And my oxygens, I have 2 oxygens and 2 times 1, 2 oxygens, so this is now balanced. Let's move on to a different example. So here we have an organic chemistry example. So an example where we've got carbon, hydrogen and oxygen present. So step 1 again, word. Step 2, formula. And step 3 is balance. Petrol, which is octane, burns in a plentiful supply of oxygen to produce carbon dioxide and water. So my reactants are octane and oxygen produce carbon dioxide and water. Step 2, let's write the formula for this. Octane is a alkane, it's a hydrocarbon, it has 8 carbon atoms and 18 hydrogens. Oxygen is a diatomic element, so it's O2. Carbon dioxide, it's got a prefix in there, so we know it is CO2. And water, we know the formula to be H2O. Let's rewrite this and balance it. Now when you have carbon, hydrogen and oxygen present, always go in show order. So let's start with our carbons. We have 8 carbons here and only 1 on this side, so we must put a big 8 at the front. And then we go back to the left and we check 8 carbons and 8 carbons. Moving on now to our hydrogens, we have 18 hydrogens here and we have 2 hydrogens there. We know that 9 times 2 is 18, so we can put a big 9 in front of this hydrogen. And then check. 8 carbons, 8 carbons, 18 hydrogens, 18 hydrogens. Now you have to count your oxygens. We have 2 oxygens here. We have 8 times 2 oxygens on this side. And we have 9 times 1 oxygen on this side. So in total, we have 25 oxygen atoms. There are 2 ways that you can show that here. The simplest by far is to leave it as a fraction. You can show this as 25 over 2 oxygens, and when this 2 and this 2 are multiplied together, that leaves us with 25 oxygens, or you could write this as 12.5 O2. Both answers are correct. I hope that those worked examples have been useful for you, they've been helpful. What I'm going to do now is pop some questions up, so you can see these here. And if you want, you can pause the video and attempt these on your own for practice, and then come back and we will look at these together and you'll be able to see the worked examples. There are 8 questions here. So I'll let you pause this, and if you want to do all 8, just make sure to fast forward for a little bit and see the last few here. Pause now if you want time to work on these on your own. Okay, now that you're back, we are going to work through these examples together so you can check your answers. Carbon burns in a plentiful supply of air to form carbon dioxide. Step 1, write your word equation. Carbon plus oxygen gives you carbon dioxide. Step 2, write your formula equation. Carbon plus oxygen gives you carbon dioxide. If you are struggling with how to work out the formula for any of these compounds, then make sure you go back and watch my previous videos on writing formula. And let's now conduct our left to right check just to see if our equation is balanced or not. Here we have one carbon and one carbon, so they're balanced. Two oxygens and two oxygens, so those are balanced too. So that's a nice easy one, and we can move on. Carbon burns in a limited supply of oxygen to form carbon monoxide. Our formula equation is the same for our reactants as in number 1. This time it changes when it comes to our product. It's mono for 1, so it's carbon monoxide like that. Let's just copy step 2 directly. And let's start our left to right count. Here we have one carbon and one carbon, so they're balanced. Here we have two oxygens and one oxygen. So we need to multiply this oxygen by 2 to make it balanced. Now we go back and do our left to right check. Here we have one carbon, but on the reactant side, our product side, we now have 2 carbons. So what we need to do is put a big 2 at the front. And again, as soon as you made a change, go back to the left and check everything again. 2 carbons and 2 carbons. 2 oxygens and 2 oxygens. So this is now balanced. Example 3. Hydrogen gas reacts violently with chlorine gas to form hydrogen chloride. Step 2. Both hydrogen and chlorine are diatomic elements, so they have a little 2 after the element symbol. Hydrogen chloride, you can work out the formula for this using the valency rules. And step 3, let's work on balancing this. So here we can see we have 2 hydrogens. On this side we only have 1, so we must put a big 2 at the beginning. Let's go back and check. 2 hydrogens and 2 hydrogens, balanced. 2 chlorines and 2 chlorines, balanced. So this equation, this formula equation, is now completely balanced. Let's move on to number 4. Sulfur dioxide gas reacts with oxygen to form sulfur trioxide gas. So our word equation reads sulfur dioxide plus oxygen gives you sulfur trioxide. Our formula is SO2 plus O2 gives you SO3. And the first step of balancing your equation is, of course, copying it down again. Starting from the left hand side, we have one sulfur here and one sulfur there. So they are balanced. We have 2 oxygens here and 2 oxygens here. So now we've got 4 oxygens and we only have 3 over here. Now when you see an odd number, the easiest way to balance an equation is to multiply it by something that is going to make it an even number. So if we put a 2 here, we now have 6 oxygens, even number, and we have 2 sulfurs. Let's go back to the left and count again. 1 sulphur, 2 sulphurs. So let's put a 2 here. Now I have 2 sulphurs here and 2 sulphurs there, so that's balanced. I have 2 times 2, so 4 oxygens here, plus an extra 2 oxygens. So I've got 6 oxygens on my reactant side. And now I've got 2 times 3 equals 6 oxygens on my product side. So this is balanced. Let's move on to our last set of examples. Methane burns in oxygen to form carbon dioxide and water. Methane plus oxygen yields carbon dioxide and water. Step 2, let's write our formula. And step 3, write it down again before you begin to balance. Now we have carbon, hydrogen and oxygen here in this question, so we're going to do things in CHO order. So starting with our carbons, we have 1 carbon on our reactant side and 1 on our product side, so we can see they're balanced. Then we go to our hydrogens. We have 4 hydrogens on our reactant side, only 2 on our product side, so we must multiply that by 2 to balance them. So 1 carbon, 4 hydrogens, 2 times 2 is 4 hydrogens. And then on to oxygen. Here we have 2 oxygens on our reactant side, and we have 2 oxygens plus 2 oxygens on our product side. So 2 on our reactant side, 4 on our product side. So we must go and put a 2 here to have the same number of oxygens. And then you go and do your left to right check. 1 carbon, 4 hydrogens, 2 times 2, 4 hydrogens. 2 times 2, 4 oxygens, 2 oxygens plus 2 oxygens, 4 oxygens. So this is balanced. Example 6. Magnesium and fluorine gas react together to form magnesium fluoride. Fluorine is of course spelled wrong here, with typo. Step 1. Magnesium and fluorine react together to form magnesium fluoride. Step 2, let's write a formula. Magnesium plus fluorine, fluorine's diatomic, gives you magnesium fluoride. You will need to use the valency rules, so using symbol valency swap divide formula to work out the correct formula here. Step 3, copy down step 2 and then do your left to right check. 1 magnesium, 2 fluorines, 2 fluorines. So this one's balanced. It's a nice easy one for you guys. Number 7. Sulfuric acid and sodium hydroxide react together to form sodium sulfate and water. Sulfuric acid plus sodium hydroxide form sodium sulfate and water. Step 2, let's convert this into a formula equation. And step 3, balance it. Again, you can start with any of these that you want to. The species that pops out to me first is the sodiums. So on our product side we have 2 sodiums and we only have 1 on our reactant side, so that's the thing that I'm going to balance first. So put a big 2 here. So now when I check it, I have 2 sodiums and 2 sodiums. Here I've now got 2 oxygens and 2 hydrogens. And remember, you've got this kind of this sulfate ion. So the way I tend to think of this is keep it in a bracket. Keep this one in a bracket so you can see that these are balanced. Let's have a look and break down these last few symbols. So here we have 2 oxygens. Over here we've only got 1. So the easiest way to fix that, we put a big 2 at the front. So we now have 2 oxygens and we have 4 hydrogens. If we go back to the left and start counting, 2 hydrogens plus 2 hydrogens is 4. 4 hydrogens, balanced. 1 sulfate ion, balanced. 2 sodiums, balanced. 2 oxygens and 2 oxygens, so this is now balanced. And our very last example. Nitric acid plus calcium carbonate react together to form calcium nitrate, water and carbon dioxide gas. So nitric acid plus calcium carbonate yields calcium nitrate and water and carbon dioxide. Writing this as formula. Again, the first part of balancing your equation is simply to write it again. Now when looking at this, the first thing that again pops out to me is this nitrate ion. So on our reactant side we only have 1 of them. On our product side we have 2. So my first step would be to put a big 2 at the front here. And then we do our left to right check. So here I've got 2 hydrogen ions. And I've got 2 hydrogen ions, so they're balanced. I've now got 2 nitrate ions. 2 nitrate ions are balanced. 1 calcium, 1 calcium. 1 carbon, 1 carbon. 3 oxygens. And over here I have 2 plus 1, 3 oxygens. So this equation is now balanced. I hope you found that useful. If you are struggling with working out your formula, and that is where you are encountering a problem when it comes to balancing your equations, make sure that you go back and watch the previous video series on writing formula.